Hey everyone, in this video I'm going to show you the most typical position for a joint to be unstable in. So which way is it going to be the most unstable? But in order to answer that, I need to just kind of review some of the key motions of a joint and the structures of the joint. So this is obviously just a pool toy that I cut up, but it's going to be the model that I'm going to use today. This is delineating the zygapophyseal joint or the facet joint. Okay, and the facet joints sit at an angle like this when viewed from the side, but they also have a sort of scallop shape like this. And then at the front, we have what we call the uncovertebral joint, where there's like a little dish shape here and allows the joint to shift from side to side like this as well. So this is obviously not super accurate, but it can show some of the key components that I need to show you. So the first thing is that when we try to think about rotation of a joint, the joint can't actually simply just rotate like this, because what will happen is the facet joints bang against each other. They're actually designed to slide over each other. So as one facet goes up, the other facet can come down, and that's what gives us rotation. But at the same time, what it will do is it'll create lateral flexion. So you see how the joint shifts to the side like that. So whenever we rotate, we have a coupling motion. So we have what we would call rotation coupled with lateral flexion. So that's lateral flexion, that's rotation. This is viewed from the back, obviously. So the joints will naturally couple as one joint slides up and the other slides down. Okay, and I would just call that rotation because the axis of rotation is basically about here. It's not in line like this. It's sitting at an angle like that. So if you imagine it's perpendicular to the facet joint, it's going to just move in relation to the facet joint. Okay, so that's the easiest way to look at what we'll call rotation. Rotation with a big R, that's rotation. It's just that coupled motion. Okay, there is another type of motion in the cervical spine, which is a translation motion. Okay, so that's kind of a straight line motion where both facet joints, you can see, are going in the same direction. Now that could be going just straight forward and back like this, or as we'll talk about more in a moment, it could be going at angles off straight. Okay, and that's a really, really key thing and kind of the focus of what we're getting to. But I want to just quickly clarify one of the difference is that when when one joint slides up or back, we call this motion sliding up, forward over the joint below it. We call that protraction. That's kind of like if you sort of stick your neck way out, what you're going to be doing is gliding these facet joints and your body can protract. So each joint will kind of work in kind of a stair-stepping way over the one below it. So that will stick your chin way out if each joint does it. And this will draw your chin back if you pull back. Okay. Now, that's protraction and retraction. Protraction and retraction aren't that far from flexion and extension. Flexion is basically a protraction with flexor contraction and extensor relaxation. So it's basically you protract and move like this. These muscles get tighter, these muscles get looser. Okay, and if you contract the extensor muscles and relax the flexor muscles and retract, that's extension. So this is extension, okay, and this is flexion. Obviously, forgive the model, it's not completely accurate, but it gets the basic idea. That's flexion and extension of the cervical spine, okay? And protraction and retraction have less of that tilting function. So protraction, retraction. So we do have a control over that. And there is sort of a pivotal center here, which you could see would be in the joint below it as you're creating flexion and extension. A lot of people focus a lot on that, but it's a very simple mechanism, okay? So the next most interesting motion is this protraction and retraction, but actually at an angle coming off center. This is very, very interesting because this is a super, super key motion in locomotion or when we're walking. Because what will happen is the joint will get shifted this way. And the reason it does it is if you imagine you were to take a step with your left foot, what's happening is your body is moving forward. Obviously, there's gravity acting on you. You're going to be coming down to the ground. But your left foot's going to hit the ground, and your leg is going to be absorbing some of that compressive force. But because it's your left foot, what's happening is you're stepping off from your right foot, and your body is shifting towards the left. Your left foot hits the ground. This lower joint is going to take some force. It's basically your body's stopping in the ground. Your foot's stopping, but your body is continuing forward. what's going to happen is there's going to be a shear force that's introduced into all of the spinal joints, which would be in the direction of that foot, okay? And we have posterior muscles here, which are going to, intrinsic muscles, which are going to resist that motion. When they're contracting, it's going to resist that joint from going like this. If those muscles have been weakened, the joint will move too far this way, okay? Or if you have some sort of a slip or a fall and your body gets shunted this way, you're really going to feel it more because you don't have that ability to stabilize this joint. So if we lose this intrinsic muscle tension here, what will usually happen is that the muscles opposite will become tighter. So these flexor muscles on this side will become tighter, okay? And the joint will shift in this direction. So in other words, it'll be partly protracted and anterior over the joint, over the bone below it. And that's kind of what we would call a subluxated joint. Okay, it's a very, very typical presentation, is that we've had some sort of an injury which has made these muscles too long or too loose. So you have a weakness of these muscles. And in the low back, we say, oh, it's a multifidus weakness. We need to strengthen the multifidus. Well, it's not really as simple as that. This usually happens as a result of some sort of an injury, a very, very fast shunt to the body, or you fall and boom, you get your body moved in one direction or another quite abruptly. And what it can do is it can actually, that very, very fast stretch can actually decrease the strength or the length of these, or decrease the tension within these muscles or capacity of these muscles to contract. So a very, very fast stretch can reset that muscle to essentially a new length, and then it makes it harder for that muscle to work and to protect the joint. So these muscles at the back of the spine are actually very instrumental in limiting this motion. Because again, as your foot hits the ground, your lowest bones are going to stop first, and then each bone above it, like a stack of boxes. You're running along with these boxes. The first box hits the ground, boxes are going to continue on forward. But they're continuing forward at an angle like this because it's your left foot or your right foot. So this sort of motion is really, really key. So if your body isn't able to stabilize in a particular joint or in a series of joints, then what's going to happen is you're going to have a weakness. And those are the people that they sort of bend over to pick something up. And when they need these muscles to work to hold this joint together, it's not going to. And what will happen is the joint will move too far, and you'll end up with the joint moving too much and start to create some injury in the joint. You might end up with some extrinsic muscles, like your rectus spinae, contracting to try to hold the joint back this way. But as we know, that's not super effective and can create its own sets of problems. So this is the key motion that becomes unstable. And as a result of these muscles being too loose or too long, in other words, we can't activate these muscles, then the antagonistic muscles, the opposite muscles to those, if these can't switch on, I'll put it this way, when these switch on, it turns these off, okay? But when these can't turn on, they can't turn these off. So these muscles will just get tighter, okay? These are too loose, and these get tighter, and then your joint will be stuck like this. So if we try to take it from this position, this sort of left anterior position, and try to move it back towards a neutral position, we're going to find a resistance of that joint to come back to neutral. And that's what I'm talking about with adjusting to neutral, is we're actually looking at this muscle tension on one side. We take the joint into that position, and then we try to feel where we feel resistance. And if this muscle's been made too weak, then this one is too tight, and we're going to find a resistance of that joint to come back to neutral. And that's all that we do in adjusting to neutral, is just hold the joint in this position and then drive it back towards a neutral position. That stretches these muscles in the same way that these were overstretched. We can actually stretch these in a very precise way, but just finishing the joint at a neutral position, so it's not going to put any stress on ligaments, but we can create a long-term change of that muscle tension. And because these then will relax, it will stop turning these off, and then these have a better chance of switching back on. And there's a whole bunch of mechanisms and things we can do to make that happen as well. But the basic idea of this video is just to explain a little bit about the motions. We have rotation with a big R, okay, and we have translation motions, which are called protraction and retraction. But that can also happen at angles, and very, very, it does every moment of every step. You have this shunting motion where the joint gets shunted one way, and then your body is going to try to stabilize the joint. If it doesn't, then we're going to have failures of these muscles here, these intrinsic muscles, which everyone knows about, but then these anterior muscles on the opposite side will be too tight, and that will disallow the joint from coming back to neutral. So that's really the key function of what translation is and how it relates to other joint functions. And just quickly, a little bonus is that if the muscles on this side are tight, that's also going to affect the rotation, because we really need the muscles all around the joint to be of equal strength and capacity to be able to manage this type of rotation. If the muscles over here are tight, then when we try to rotate the joint, we're going to see like a strange sort of motion, because what it's going to do is the axis of rotation will shift towards where the tension is. So the tension's over here, and the joint's like this, and the joint's going to move in kind of a weird way, where the axis of rotation is now in a different place. And we'll sense that when we feel someone's joint. We'll go, oh, this feels really weird. It's not moving quite the way that it should, because this axis shifts towards that tension. Everyone could probably understand that. If there's tension here, it's going to hang everything up and make all this move too much. And then basically you're going to say, oh, this is unstable on this side. But if we try to fix that with a rotational motion, what we're doing is we're actually stretching all of the muscles all around the joint. Well, not all of them, but at least half of them, stretching it by trying to move it in a rotation. But it's not going to be nearly as specific as it would be if we put the joint where it was and drive it back towards a neutral position. So anyway, that's how that works, and I hope that makes some sense to you. Thanks for watching.